Let's take a look at section 2.7, where we're looking at linear inequalities in one variable. A solution set of an inequality is the collection of all solutions to the inequality. Set builder notation is one of the ways we use to express a solution set of an inequality that contains an infinite number of values. Interval notation is another way that we express a solution set of an inequality that contains an infinite number of values. So in all, we will have three ways that we will show solution sets. We can show them as a graph, as an interval, and using set builder notation. And these particularly are solution sets where there are an infinite number of values in the set. So here we have the table that's relating how you would show the set of all numbers between A and B. Notice this doesn't include A and B. The open circles above A and above B show that the A and B, which are called endpoints, are not included. And we shade the portion of the number line between these two values. Here's how that set looks in interval notation. Parentheses beside the A and the B in the interval notation show that the A and B are not included, but everything in between A and B is included. And here's how we write that as using set builder notation, which includes an inequality. Now the next set is not only all the numbers between A and B, but this set includes A and B. So notice instead of open circles on the number line graph, we have solid circles. When we write interval notation for all the numbers between A and B, including A and B, we use square brackets to show that these endpoints A and B are included. When we write this as a compound inequality, we use this compound statement that this is the set of all x such that A is less than or equal to x and x is less than or equal to b. So these three describe the same set of numbers, just in using a different method of representation. I sometimes have a set of this nature where I include one endpoint but not the other. So in this first picture, the A is not included but the B is. So an open circle is at A, a closed circle at B on the number line graph. On interval notation, a parenthesis is at A since it is not included, and a bracket is at B since it is included in the set. And again, we're including all the numbers in between. And then when we write this using set builder notation, the inequality portion of that notation has simply A less than x. Notice there's no equals to there, which means the A is not included, and x less than or equal to b, indicating the b is included. Here we have a similar situation, but we are now including A and not including B. Open circle above B on the number line, closed circle above A, bracket beside A, parenthesis beside B since B is not included and A is included. A is less than or equal to x and x is less than b. Here we have a situation where we're not including the A, but we are including all numbers to the right of A. So we have a parenthesis beside A on the interval notation, and the symbol positive infinity, which is always enclosed with the parenthesis because it is not a number. It cannot be included. It's a pattern of behavior. So the positive infinity means indefinite movement to the right. So on the number line graph, that's shown with an arrow, an infinity symbol, and interval notation. And in the set builder notation, I simply, in the inequality portion of this, write x bigger than A. Here, I want the set where I don't include B, but I want everything to the left of B. So indefinite movement to the left is shown in interval notation with a negative infinity symbol, which always is to the left, always enclosed with a parenthesis. It is not a value that can be included, but it represents a pattern of behavior. Here, a parenthesis beside the B, which is not included. And as an inequality, that's written as x less than B, the set of all x such that x is less than B. And our final graph is similar to the previous one, but now I'm including the endpoint A in the first graph and the endpoint B in the second. So the only difference here is when I write the interval notation, I enclose with a bracket the included endpoint, A in this first case, B in the second. Indefinite movement to the right, indicated with the positive infinity symbol. Indefinite movement to the left, indicated with a negative infinity. And notice these infinity symbols are always enclosed in interval notation with parenthesis. Negative infinity is always to the left of the interval. Positive infinity is always to the right of the interval. And here, because we're including the endpoints, this is the set of all x such that x is greater than or equal to A. This is the set of all x such that x is less than or equal to B. I have an addition property of inequality, which works very similar to the addition property of equality. And that basically says I can add or subtract the same quantity C from both sides of an inequality, and I get an equivalent inequality, which means that inequality has the same solution set as the original inequality. So if A, B, and C are real numbers, if A is less than B, then A plus C is less than B plus C, and A minus C is less than B minus C. And here you could replace the less than with less than or equal to, or you could replace it with greater than, or with greater than or equal to. And you would have three corresponding statements. There's also a multiplication property of inequality, which says if I multiply or divide both sides of an inequality by a positive number, I get an equivalent inequality. If I multiply or divide both sides of an inequality by a negative number, C is negative, I switch the direction of the inequality, and doing so results in an equivalent inequality. So if A is less than B and C is positive, meaning C is greater than 0, then AC is less than BC, and A over C is less than B over C. So notice how the inequality symbol, if C is positive, maintains its original direction. Now if A is less than B and C is less than 0, then A times C is greater than B times C, and A divided by C is greater than B divided by C. So notice here, when my C is negative, the original inequality symbol reverses direction. So this less than became a greater than, whether I multiply or divide by a negative value.